Number 15. Calculate the volume in liters occupied by each of the following. So we have number of moles, we have kelvins, and we have atmospheres. So since we're being asked for volume, we have 1, 2, 3, 4 terms of ideal gas law. But we also have R because we can calculate R at any point. So let's rearrange this equation to solve for volume, because that's what we're going to be doing. So volume is equal to nRT over P. And so V is equal to nRT over P. So let's put these numbers in. So let's see, we have 2 moles. We have R. We have the temperature, which is already in kelvins, so that's cool. And we have the pressure. And we're ready to calculate. Two times 0.821 times 300 divided by 1.25. Now I'm looking for 3 sig figs based on this question, so I'm going to go 39.4. And moles cancels with moles, atmospheres with atmospheres, kelvins with kelvins, and that liter is the only thing I have left. Good thing, because that's actually what I'm being asked to solve for right there. We get 39.4 liters. Next up, B, we have these set of quantities to use. Notice that I'm given degrees Celsius. I need to turn this into kelvins. So let's just do that real quick. Plus 273, 310. This is actually 310K. Okay, and this will have 3 sig figs. Okay, so volume is equal to nRT over P. Plugging in these values, 0.425 moles, and then 0.821. And then see, what's my temperature? Oh yeah, 310 K over 0.724 ATM. Moles with moles, atmospheres with atmospheres, kelvins with kelvins. That liter is the only thing I have left, and we're ready to calculate. 0.425 multiplied by 0.0821 multiplied by 310, and then divided by 0.74. Again, going for 3 sig figs here. Looks like that's gonna stay at 14.9. I'm gonna drop that 4 for 14.9 liters. And number 4, a couple things. I noticed that I'm given a degrees Celsius again right there. I like to immediately get rid of those so I can just start doing my calculations downhill. So that 57 degrees Celsius plus 273 gives me a temperature of 330 Kelvin. But notice that I have 4 grams of O2, and for the ideal gas law I need moles, so I'm going to convert 4 grams of oxygen into moles of oxygen using a regular old-fashioned conversion factor, grams of O2 on the bottom and moles of O2 on the top. For every 1 mole of O2, I have 32 grams of O2 because if you look at your periodic oxygen for each mole is 16.0 grams, or you can say 15.999. But there are 2 oxygens here. It's an O2 molecule, so we need 32 grams. So grams cancels with grams, and 4, got an ant here, 4 divided by 32, end up with 0.125 moles of O2. So that's what I'm going to plug in for my N value. nRT over P. So 0.125 moles, still using the 0.0821 liters atmospheres over Kelvin, and my Kelvin is 330 K, all over my pressure. Moles cancels with moles, atmospheres with atmospheres, kelvins cancels with kelvins, and so I'm left with only a volume. And I'm ready to calculate and finish up number 50. 0.125 moles, because I had to convert that 4 grams of oxygen into moles of oxygen, times the ideal gas constant for these units. That temperature is 330 K, and then divide by 0.888. End up with 3.18. Still going with 3 sig figs with the way this question is set up. I'm going to go with 3.81. Now, notice this setup, right? Because using the ideal gas law is not that hard, right? We've done 2 problems here, number 14, now number 15. Using the ideal gas law is not difficult. The only thing that I could see getting you messed up is not recognizing that you should use the ideal gas law, maybe considering using something like the combined gas law, or maybe one of the individual gas laws. But please note, there's no changing conditions here. It's not like we have a P1 and a P2, or a V1 and a V2. It's just one set of circumstances, one set of conditions, and we have values for all these terms, right? We'll be given 4 out of the 5 of these, including R, right? It's not that we're quote-unquote given R. We're supposed to know what R is at that. And then the question will give us the 3 other quantities, and then we solve for the last one, right? Notice in A, B, and C, we're actually given 3 quantities, and we solve for the other one, right? That is your red flag. There's no change in conditions, and we just have a whole bunch of givens.